In this video, I'm going to go over topic 315 about rates of change in polar functions. So one thing that we're going to look at is what increasing and decreasing look like on a polar graph. We know what increasing and decreasing look like on a regular normal graph, but what we're looking at here is the thing that is increasing or decreasing is the distance to the origin. Which is our R value. So if our R value is positive and increasing or negative and decreasing, that means the distance from the origin is increasing. And we're going to look at this on a rectangular graph as well. If it's opposite, so if it's positive but decreasing or negative and increasing, it's going to be getting closer to the origin, which means the distance is going to be decreasing. So let's look at, this is the rectangular graph for this polar curve. So this is 1 plus 2 sine theta, this is 1 plus 2 sine x. So just kind of walking through the relationship here. At 0, our graph is at 1. And then at pi over 2, our graph's up at 3. At 7 pi over 6, we reach pi is at 1, so that's this point. This intersection is at 7 pi over 6. 3 pi over 2 is at a negative 1, which is where this little inner loop is coming from. And then it goes back to 1. So it's easy to see the two characteristics we're looking for, positive, negative, increasing, and decreasing on a rectangular curve. So here we're going to look for where is f positive and increasing. So positive means above the x-axis, negative means below, and then increasing and decreasing are the y values going up or going down. So positive and increasing, that's going to be from 0 to pi over 2. And then again from 11 pi over 6 to 2 pi. Next, we're going to look at positive and decreasing. So still above the x-axis, but going down now. So that's going to be from pi over 2 to 7 pi over 6. Okay, and then negative and increasing, that's going to be from 3 pi over 2 up to 11 pi over 6. Okay, and then negative and decreasing occurs here, from 7 pi over 6 to 3 pi over 2. Okay. So again, kind of relating the two graphs, here this is positive and increasing. The distance between the x-axis and this curve is increasing. Well, what's happening here is as I plot these R values, those R values are farther and farther away from the origin until we get to B. At B, the R values, so here these start getting closer to the x-axis, which means these values are getting closer to the origin. And that occurs until 7 pi over 6 when it turns negative. So these values are pulling away from the x-axis. They're getting further. So here we're getting, further away. So here it's getting farther away. Then 3 pi over 2, it's negative and increasing. So it's going to start getting, sorry, I was saying that incorrectly. At 7 pi over 6, so it's decreasing. Then as soon as we hit 7 pi over 6 here, it starts getting farther away, but it's negative. So since this is negative and decreasing, that is, the distance is increasing. Then at 3 pi over 2, it starts getting closer again until 11 pi over 6. Then it starts getting farther away. So we're going to put that information down here. So the A, B, C, and D come from this diagram here. So from A to B, my graph is here, we said, is positive and increasing. Here, those points are moving farther away from the origin, which means the distance between the origin and our graph is increasing because it's positive and increasing. From pi over 2 to 7 pi over 6, it's positive and decreasing, so the distance is going to be decreasing. 7 pi over 6 to 3 pi over 2 is negative and decreasing, which means the distance is increasing until we get to 3 pi over 2, when it changes to increasing but negative. So those values are getting closer to the origin, which means that distance is decreasing. And then finally, this last little chunk is positive and increasing, and the distance there is increasing from the origin. So the rectangular graph is really important and really helpful in determining this increasing and decreasing thing. So my example here, consider the graph with the polar function r equals f of theta, where f of theta equals 2 plus 4 cosine theta, minus 4 cosine theta, in the polar coordinate system from 0 to 2 pi. Which of the following statements about the distance between the point and the origin is true? So we have the distance is increasing for pi to 5 pi over 3 because the f is positive and increasing on that interval. It's increasing here because it is negative and increasing. Well, that can't be. If it's increasing, if it's negative and increasing, it's actually decreasing. So we're going to get rid of that one. Here, the distance is decreasing because it is positive and decreasing. That could be true. This says it's decreasing when it's negative and decreasing. Negative and decreasing would mean it is increasing. So now we just need to determine which of these is true. Is it increasing or decreasing? We have the justifications set. It's just which one of these is true. So I'm going to turn to the rectangular graph. The amplitude is going to be 4. My period is going to be 2 pi. And I have a vertical shift or a midline at 2. So I'm going to draw my rectangular graph. My midline is at 2, and then we have an amplitude of 4. So we're going 4 above that and 4 below that. So down to -2, up to 6. And this is going to be a negative cosine, which means the negative cosine is going to start at the bottom, or the minimum, then go to the midline, then to the max, then the midline, then back down. Okay, so here we're looking at between pi and 5 pi over 3. So from pi to 5 pi over 3 is going to be this section of our graph here. Okay, well, it is negative and it's positive and decreasing. So the distance is decreasing from here to here because the graph is positive and decreasing. The distance from here to the x-axis is getting less. Okay, here we have a graph of 3 sine 2x between 0 and 3 pi over 2. We are trying to determine if the polar graph that we don't have in front of us, where the distance is decreasing. Okay, so I'm going to look at each of these intervals. 0 to pi over 4 is positive and increasing, which means the distance would be increasing. From pi over 2 to 3 pi over 4, it is negative and decreasing, which means it's moving away from the origin, so that distance is increasing. 3 pi over 4 to pi is negative and increasing, which means the distance as we go here is decreasing. This is a big distance, this is a small distance. So that will work, but let's check this last one. Pi to 5 pi over 4, just like the first one, is positive and increasing. So kind of a way to remember that is if it's kind of the same positive increasing or negative decreasing, the distance is going to be increasing, and if they're kind of opposites, negative increasing, positive decreasing, it's going to be decreasing. The distance is decreasing. Okay, next we're going to talk about relative extrema. We've talked about this on rectangular graphs, whether you have a local maximum or a local minimum. We've talked about how that happens. What we're interested in for polar is if r of theta changes from increasing to decreasing or decreasing to increasing, then the function has a relative extrema. meaning it's the point that's either closest to the origin or farthest from the origin. So we're going to look at 1 minus 2 sine 2 theta between 0 and pi and figure out which of these statements are true. So this has a relative minimum on this interval because r of theta changes from negative to positive. That is not going to get us a max or a min. We're looking for increasing and decreasing. So this one, a minimum because the graph changes from decreasing to increasing, could be true. This has a max because it changes from positive to negative. Nope. And then here has a relative max because the graph changes from increasing to decreasing. So both of these are plausible, but we need to graph this to be sure. So for this one, my amplitude is 2. My period is 2 pi over 2, which is pi. And I again have a vertical shift or a midline of 1. Okay, so I've marked my axes here going out to pi. My midline's at 1 with an amplitude of 2 means I'm going up as high as 3 and as low as down as negative 1. And it's a negative sign. So negative sign is going to start at the midline, go down. Like so. So the interval that we were interested in is pi over 3 to 2 pi over 3. 2 pi over 3 to pi. Well, here's pi. 2 pi over 3 is going to happen after pi over 2. This is so about here maybe, a little bit past 2 pi. So from 2 pi over 3 to pi, the graph goes increasing to decreasing. So it's getting farther from the origin, then it starts getting closer to the origin. So at this point, we have a local maximum. So that's going to be option D. This other interval that I already kind of eliminated from pi over 3 to 2 pi over 3 is always increasing, so it's not going to have a relative maximum in there. Next, we have average rate of change. So the average rate of change, just like day 2 of AP Precalculus, is f of b minus f of a over b minus a. For a rectangular curve, that's the slope of the secant line, the slope through those 2 points. Polar, that's not quite the case. Geometrically, the average rate of change indicates the rate at which the radius is changing per radian. So how far away the points, the r values are, and what changing at what rate. So really straightforward. Same formula, just new functions to deal with. So we have the function 3 minus 3 cosine theta. We want to know what's the average rate of change on the interval pi over 2 to pi. So it's always f of b minus f of a over b minus a. In this case, that's going to be f of pi minus f of pi over 2 over pi minus pi over 2. I'm going to do these off to the side here. Okay, cosine of pi is negative 1. So if I have 3 minus a negative 3, that's going to be a positive 6. Cosine of pi over 2 is 0, so 3 minus 0 is 3. So back to my formula, we have 6 minus 3 over pi minus pi over 2. 6 minus 3 is 3. Pi minus pi over 2 is pi over 2. So if I multiply by that reciprocal, we get an average rate of change of 6 over pi. Okay. So we have the graph of a rose here. And we are asked, so it's 3 sine 2 theta, so we've got our 4 petals. Which of the following statements about the average rate of change is 0? Well, if my formula is f of b minus f of a over b minus a, and my result is 0, that means f of b minus f of a needs to equal 0, which means we're looking for where f of b is equal to f of a. It's kind of hard to tell on the polar curve though, because we know all these points that we're talking about, 3 pi over 4, pi over 4, 7 pi over 4, the r value there is 3 or negative 3. So what I'm going to do is go ahead and graph the rectangular graph, amplitude of 3 and a period of pi. And I'm going to graph all the way to 2 pi, though, because I want to see the full thing. Okay, so I'm going out to 2 pi, but we complete a cycle every pi units. So from here, I can look at what those values are, and I'm looking for 2 that are the same. So pi over 4 has a value of 3. 3 pi over 4 has a value of negative 3. 3 pi over 4 is still negative 3. 5 pi over 4 is positive 3. 3 pi over 4 is negative 3. 7 pi over 4 is negative 3. So this is going to be our option, because if f of 7 pi over 4 equals f of 3 pi over 4, we get 0. This last one is a positive and a negative again, so that's not going to work. And just quickly, so on the rectangular curve, that slope is 0. So on a rectangular curve, the average rate of change is our slope. But here, 7 pi over 3 and 4 pi over 3, if I drew a line through that, it's just not the same thing. Okay, next we have a graph here. It's shown from 0 to 2 pi. On the interval, the graph has no holes, passes through each point exactly 1 time. As theta increases, the graph passes through the points A, B, C, and D in that order. So A, B, C, D. On which of the intervals is the average rate of change with respect to theta the least? Okay, well, if I look from A to B, my R values are going to be the same. So just like the problem, previous problem, my rate of change is going to be 0 here. From B to C, my R went from a smaller value to a big value. So my rate of change is going to be positive, okay, because the R values are increasing. From C to D, the R value is the same. So this is another 0 rate of change. And then from D to A, we went from, 5 point something, or maybe about 5, down to about 3. So those are decreasing. It's getting closer. So this is going to be the smallest, because we have a positive number, 2 zeros. Smallest is going to be our negative rate of change. Okay. Next, we're going to use the rate of change to predict values in between an interval. So we're going to use the point slope form of a line. So point slope form of a line is y minus y1 equals m x minus x1. The m is going to come from our average rate of change. The x1 and y1 is going to come from our point. Now, converting this to a polar idea, I can add the y1 over. So my point is going to be, this would be my x1, this is my y1, or theta, and the function value at theta. And then we have our average rate of change for the slope. Okay, so let's look at an example. It says the table gives values of the polar function r equals f of theta. Selected values are given. Use the average rate of change from pi over 6 to 7 pi over 6 to approximate 5 pi over 6. Okay, so first I'm going to find my average rate of change, or my slope in this case. It's not really slope though. That's good. So this is going to be f of 7 pi over 6 minus f of pi over 6 over 7 pi over 6 minus pi over 6. According to my table, that's negative 1 and 2. 7 pi over 6 minus pi over 6 is 6 pi over 6. So this ends up being negative 3 over pi. So we're going to write an equation. Okay, I can use either of these 2 points. I'm just going to use this one. So my function value is 2 plus my slope. Oh, my slope's negative, so we'll make this minus 3 over pi, and then in parentheses, theta minus pi over 6. So here's my point, there's my slope, and then we're going to predict what happens at 5 pi over 6. So 2 minus 3 over pi, 5 pi over 6 minus 1 pi over 6 is 4 pi over 6. To make my life easier, we'll go ahead and reduce that fraction to 2 pi over 3. Then we have our cancel party, and we get 2 minus, all that's left out of this is 2, so we're saying that f of 5 pi over 6 is approximately 0. So this was your last AP Pre-Calc topic, 315.